Graphs of quadrics. A quadric is a set of points satisfying the quadratic equation ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. These equations involve many constants a, b, c, d, e and f, 6 of them. But if we use completing the square, then we can make this equation a lot simpler, and we can rewrite it to an equation of the form alpha x1 squared plus beta y1 squared plus gamma is equal to 0, or alpha x1 squared plus beta y1 plus gamma is equal to 0, where alpha, beta and gamma are just constants. So there are only 3 constants involved now. After scaling, we can even restrict to 3 types that are familiar to us, namely a circular ellipse, a hyperbola, or a parabola. The equation for an ellipse is x divided by a squared plus y divided by b squared is equal to 1. An hyperbola we can give as x divided by a squared minus y divided by b squared is equal to 1. Or finally, a parabola we can write as y as an equation y is a times x squared plus b. For example, if you start with a general quadric, say the quadric x squared plus 2xy plus 2y squared plus 4x plus 2y minus 5 is equal to 0. What can we do then? Well, first we use completion of the squares. X plus y squared is the part that we can see here. Well, there is still 1 y squared left. That's written here. Then we have x plus y also 4 times here. Well, up to this minus 2 times 5. And then we have this minus 5. So we can rewrite this to x plus y squared plus 4xy plus y squared minus 2y plus 5 is 0. Now, again, using completion of the squares, tells us that we can rewrite this to x plus y plus 2 between brackets square minus 4 plus y minus 1 squared minus 1 minus 5 is equal to 0. And now you see this is an equation of the form x plus y plus 2 squared plus y minus 1 squared minus 10 is equal to 0. And if we introduce the new variables x1, which is equal to x plus y plus 2, and y1, which is y minus 1, we find x1 squared plus y1 squared is 10, and we do have a circle, namely a circle with radius square root of 10, in the x1, y1 plane. Here is a second example. X squared plus 2xy plus y squared plus 4x plus 2y is equal to 0. Well, this can be rewritten to x plus y squared plus 4 times x plus y minus 2y minus 5 is 0. And here we can use, again, completion of the square to find that this is x plus y plus 2 squared minus 2y minus 9 is 0. But now with x1 equal to x plus y plus 2 and y1 equal to 2y plus 9, we find y1 is equal to x1 squared, and we have found a parabola. The circle, well, this is well known of course, can be given by an equation of the form x squared plus y squared is r squared, where r is the radius, and then we have a center at 0. We can of course rewrite this to x divided by r squared plus y divided by r squared is equal to 1, or x squared divided by r squared plus y squared divided by r squared is equal to 1. If we change the center to a point AB, then this circle with radius r around a, b is given by the equation x minus a between brackets square plus y minus b divided square is equal to r squared. The distance from an arbitrary point xy to the center AB is then given by the square root of x minus a squared plus y minus b squared, and that's indeed equal to r. So the points on the circle are exactly the points that have distance r to the center of the circle AB. So if we want a circle with center 2, 1 and radius 2, then this is given by the equation x minus 2 squared plus y minus 1 squared is equal to 2 squared. On the other hand, if we have x minus 1 squared plus y plus 3 squared is equal to 9, we have the description of the circle with center 1 minus 3 and radius square root of 9, which is equal to 3. The disk, that's the interior of a circle. So a disk can be given by an inequality, namely an inequality of the form x minus 1 squared plus y minus 2 squared is less or equal than 3 squared. And that particular example describes the set of all points at distance at most 3 from the center 1, 2. Of course, the circle has also to do with the graph of the function, which says that y is equal to the square root of r squared minus x squared. Because then we do have that x squared plus y squared is equal to r squared. But that function has a graph that only describes the upper part of the circle, half a circle. The other half of the circle is of course given by y is minus the square root of r squared minus x squared. An ellipse looks a lot like a circle, but in this case the distance to the midpoint is not constant. It varies whether you are at the x-axis or at the y-axis, for example. So an equation of an ellipse that has the x-axis and y-axis as its axis of symmetry is given by x divided by a between brackets square plus y divided by b squared is equal to 1. This ellipse passes through the points minus a0 and a0 on the x-axis and 0 minus b and 0b on the y-axis. So if we want to have an ellipse that has a center at the point 1, 2, then we have to change the equation a bit. Well, if this ellipse passes through the points minus a plus 1, 2 and a plus 1, 2 and 1, minus b plus 2 and 1, b plus 2, then we can give it as x minus 1 divided by a squared plus y minus 2 divided by b squared is equal to 1. Parabolas are quite known to us. An equation, a general equation for such a parabola, is an equation of the form y is equal to a times x squared plus b. Or even more general, y is equal to a times x minus c squared plus b. Of course, if you have the letter formula, y is a times x minus c squared plus b, you see that the top or the lowest point of the parabola is at x coordinate c and has then value b. A hyperbola can be described by a formula of the form x divided by a squared minus y divided by b squared is equal to 1. Or, of course, switching the roles of x and y by x divided by a squared minus y divided by b squared is equal to minus 1. Such a hyperbola is also given by an equation of the form x times y is equal to some constant, or y is equal to c divided by x. This might be more familiar to you. But actually, this kind of equation does not really differ from the one that we saw on the previous slide. Indeed, if we take x1 to be x plus y and y to be x minus y, then x times y is equal to x1 plus y1 divided by 2 times x1 minus y1 divided by 2. So we find that x1 squared minus y1 squared is equal to 4 times c. And we have an equation of the form of the previous slide. It's just a change of coordinates. Completing the squares gives us a method to decide whether we are dealing with an ellipse, a hyperbola, or a parabola. Here is an example. What curve is defined by x squared is equal to 2x minus y squared? Completing the square will give us the following. We start with x squared minus 2x plus y squared is equal to 0. That means that x squared minus 2x plus 1 minus 1 plus y squared is equal to 0. So x minus 1 between brackets squared plus y squared is 1. And we have found a circle with radius 1 and center 1, 0. A second example. Now start with the equation x squared plus 2xy is minus 3y squared plus 4. Again, we start with this equation by putting everything on the left hand side and find x squared plus 2xy plus 3y squared minus 4 is equal to 0. Now, completing the square tells us that we can rewrite this to x plus y squared plus 2y squared is equal to 4. And we find that we have x1 squared plus 2y squared is 4, where x1 is equal to x plus y. So we have found an ellipse.